So, to develop the machining or manufacturing technology for our toolbox, we will make a copy of our original design file. The intent here is to make a separate manufacturing file. We will bring in only part of our toolbox. Only the parts or details we actually need to manufacture are brought in purpose. And then we can start the CAM programming of these parts. As said in the reading text, we are going to utilize a 3-axis router to manufacture those parts out of a plywood of thickness 18 millimeters. And for each and every part we need to generate a CAM setup together with different toolpaths that will machine our features. So let's start. At first we will start with manufacturing or showing the example how to program the side. So for the clarity of things I will hide others, and here is the general setup of our CAM programming for the side part. In the setup we have defined our stock. That is to be argued whether the stock is of the most rational size or not. And also we have established our work coordinate system. This is established to the lower left corner of our stock in this instance. Then we will have the toolpath. Originally here we have planned to have so-called technological holes. So holes from where we will make spots, and then we can actually drill some screws in there so that they will hold the part firmly onto the CNC machine table. The second operation would be to drill out the corner reliefs of these female connecting pockets. Then there will be the roughing operation of those pockets, the roughing operation of the pocket for the handle, which there will be some special features linked to this, which we will have a look on later. The contour, the finishing operation here, and then there are the finishing operations on the mating pockets, and finally we will cut the part out from the stock. First thing to mention, or something I forgot to mention at the beginning, we will machine those parts, details, one at a time, since these are the limitations set to us by the size of our working area on our routers, which is maximum 800 millimeters only in the Y direction. Otherwise, if one has a bigger router at his or her disposal, that all these parts can be in principle manufactured from one big stock. Let's have a look on how to program a toolpath. Here we have the drill operation. Programming a toolpath in majority of the CAM programs demands for quite similar information. First you need to input information about the tool we are going to use. Then there are the cutting parameters, the spindle speed or the surface speed, the feed rates. Then there is the chaining of the geometry. Here we are just doing small spots, so we have shown some points. This is to confine the cutting tool in Z direction. We are setting the heights for our manufacturing machining process. Where is the stock top? where how deep we are going to machine and so on. And here we can set the type of the drilling operation. This is a relatively simple operation, nothing much to talk about this here. So let's have a look on the first toolpath, the simulation. These are now, it is showing how it is drilling the spots, now doing the reliefs. We'll make it a little bit slower. Drilling to the reliefs. Our routers, we are only able to use one tool. There is no tool changer, there is no tool rack, there is no carousel. So we have a 6 mm diameter router bit. It is a 1 flute end mill, and since plywood is not that hard, we are going to use that tool, the end mill, also for the drilling operation. Here we are going to drill a little bit through the material, just to be sure that we have enough clearance. Adaptive is the most common roughing toolpath. When it comes to roughing, we have another crucial parameter to pay attention to. That would be the load, meaning the radial depth of cut, AE, so to say. Again, machining wood, it is not that critical actually. We are going to leave some stock on the sides, on the walls only. No need to leave any stock on the Z. And we will enter the material with a plunge move. This is another adaptive for this. Another adaptive for clearing out the pocket for the handle. Here we have used a trick, a shortcut. Since our plan is to make separate sides, meaning that we will have a left side and we will have a right side, then we can't actually machine through the hole. we need to leave some material on the bottom, and this can be achieved by leaving a positive offset at the bottom over there. This will be simplified. This we can see much better while doing the simulation. Another very crucial thing is now with the finishing operations. Since we need to check the fits over here, we would like to be able to control the diameter of the tool from the controller. The difference here being, while using the adaptive takes the diameter of the tool from the tool library. Here it is 6 millimeters, and it calculates the toolpath following that 6 millimeters. When doing the contour, there is another option. This is a finishing toolpath. Here you see we can choose between different types of compensation. While using in computer, it means that it will stick with a 6 millimeters, nothing much we can do about it at the control with a CNC program. One of the most common ways to utilize the possibility at the control is to use the option in control. In control allows us to use the wear parameter at the offset table at the machine control. So this is how we have established it here also. The same with these mating pockets. The next operation you see is was clearing that pocket. Now it starts to clear. Here is always an option. We can have a look on the coordinates, the crucial one being set. So as you can see, the -19, we are going -1 millimeter through the bottom of the model, just to be sure that it cuts through. Finally, we will ramp out the contour. Ramping out means the tool is simultaneously moving in all three axes. As it passes in Y and X, it is also slowly ramping down at Z. There are different parameters of this toolpath one can control, like the angle of the ramp, like whether or not you would like to have a finishing toolpath at the end, and so on. So this is our principal cam setup and toolpath for the side. Another trick we are going to use is for manufacturing the other side. Let's say if this is to be our left side, then to machine the right side, we can utilize the patterning, toolpath patterning option. Very convenient. No need for the actual model either. We can mirror what we are doing here is mirroring the toolpath or the setup that made the left side. For the bottom setup, nothing much special over there. It is a different size of a billet or stock. Here we won't have so many toolpaths. Again, these are the optional holes to use as markers for the screws, so that the final part will be firmly attached to the working table. Again, there will be the drilling of the reliefs and then cutting out the part with a contour toolpath. very similar would be the toolpath for the front. Here you can see we have made an addition to our model. We have actually modeled in the acronym of the university, Estonian University of Life Sciences, and we also utilized the pocket toolpath to cut it out as a carving or alike.
Alkaa jaksamaan ja